When you think about 3D printing, the first thing that comes to mind is widgets, dragons, and wiggly bits. But the truth is, 3D printing, additive manufacturing has so much more available to it, and it goes way beyond just some plastics pushed out of a machine. What we're staring at right here, this is metal 3D printing as an end solution. Now, we didn't just accidentally end up with a metal 3D printed part. We specifically chose metal 3D printing as our end solution for various reasons. Now let's break down the different types of manufacturing we could have considered for this automotive restoration project, the why, the what, and the how we ended up on metal 3D printing as the final solution. Hey, I'm Barrett, and in this channel, we are focused on 3D scanning, design for manufacturability around additive manufacturing, which we've got 14 machines sitting behind me in our warehouse. So if you are eager to learn about the additive space and how to apply it in industry, in motorsports, in many other disciplines, then stick around, subscribe. That helps us so much. We appreciate it. We're going to keep growing and keep sharing real projects like the one right here that we work on for clients in our business. We want to share them out loud for you guys to learn and grow from. The problem auto restorers face today is that their parts just simply don't exist anymore. Either they're so worn out they can't repair them, or they just have nothing to reference, so they are forced to create new solutions for their restoration. Now, our client came to us working on a Fiat Roadster. They brought these designs to us, and the next step that we face is, what are the working conditions? What are the loads? What's the environment? And then ultimately, how are these parts going to be manufactured to serve those purposes? Sometimes we're scanning and replicating a part that already exists and we just need to make a new version of it. But in other times, we're taking an idea and we are starting from scratch to create a new solution, but that solution will look like it was always supposed to be there. That's the true difference in creating or just replacing. So now I need to show you how these parts actually lay out in the vehicle so you can understand what their purpose is. We have a rail here, we have a rail here. This is actually gonna have like a felt cloth inside of it. And then this is our control slider, and this attaches to our window. And this system allows the window to roll up and down in these tracks. This didn't exist beforehand, and now they have created it in metal 3D print. It's pretty awesome. So when we're considering our final manufacturing process, we have our conventional subtractive manufacturing methods where we're removing material to create our part. And then we have 3D printing, or also known as additive manufacturing, where we are adding material to create unique and complex geometries like this automotive restoration part right here in front of me. This specifically is a metal 3D printed part out of an aluminum alloy. So option one, conventional subtractive manufacturing, CNC billet aluminum. So CNC billet pros, well, who doesn't love billet aluminum? It'll look fantastic. We can also have a very tight control of our dimensional stability in the part. And then of course, billet CNC allows us to do one-off components. So we're not committing to a huge number of units to get our one project satisfied. Now let's look at our largest part here being over 22 inches long. The block of aluminum we would have to start with is huge, and there is a lot of material to remove. So that's a lot of material waste, it's a lot of machine time and labor. So cons for billet machining are material cost, material waste, machine time, labor, and there's probably going to be tools and fixtures necessary to hold these parts. Now, manufacturing option number two is casting. That's not one we'd typically consider from a small batch production, but it was worth evaluating due to the complexity of the part design. So casting, we create a mold that is the negative of our part, and then we are going to flow in the end material, aluminum in this case, to create the raw part. And then there'll be some post-processing to get to this level of quality. So for casting, our cons are high tooling, one-time fees to get started, long lead times to actually get to a part. But our pros are, if we were doing mass production, our part cost is going to be really low and repeatable. So manufacturing option number three that we considered is kind of my bread and butter in Contrive. Polymer 3D printing, specifically FDM style 3D printing, where we are extruding layers and building up our part in our chamber. Now, with these parts, the consideration is what is the strength? What is the load that these parts need to hold for that window actuation to happen? And when we consider how thin and lengthy that these parts are, we have to consider our layer adhesion as a major component with our manufacturing process. Now, I would say that the center part here was a good candidate for FDM style 3D printing with very minor differences to the design. It could be printed up in layers, it would be strong with say PPA CF, and it would do the job needed. But we start considering really complex geometries like these parts here with lots of overhangs, thin features, and we have to start thinking about how do we support this material in the printer and how much time are we spending in that manufacturing just creating support structure. We start adding a lot of inefficiencies due to the complex geometry. And then we have to consider, do we change the geometry to better suit FDM 3D printing? And ultimately, talking to the client, it just didn't seem like the best solution, even though that's our bread and butter, like we mentioned. So, cons of FDM style 3D printing, we may have a lot of waste because of support structure and the complex thin structures of this part. Pros, again, it's a one-off solution. We commit once, we produce the part, and there's no tooling, there's no fees, and we can action it very quickly. And to just share a bit, polymers I considered for this project were PPA-based nylons, very strong, very robust material, and actually a polycarbonate, and if we're not in extreme heat situations, can be very viable. So now we come to our fourth and final manufacturing method, direct metal laser sintering with this aluminum alloy. Metal 3D printing creates a combination of all the benefits that we have been talking about in the previous manufacturing methods. Like CNC metal, we know that we're getting the integral strength of a metal part. We have a much more isotropic, not fully isotropic as say billet, but much, much closer than say FDM style 3D printing. So we have a uniform strength in our part for the most part. We're allowed to kind of abuse our thicknesses a bit more, go much thinner, not be so dictated by the more coarse FDM style 3D printing polymers. But we get the flexibility of 3D printing, meaning we're not investing in high tooling fees, one-off costs for molds and fixtures. We get to go straight to producing the part that you see here and have very little post-processing for support removal and sandblasting and cleanup. The pros, I think, are kind of obvious. You can create very complex geometry. You don't have to invest in tooling and one-off fees. And if you're looking for a one-off solution like this project in front of us, it's very, very viable. And you can step into materials that are going to be much stronger and much more durable than, say, a polymer in its application. So let's break down the cons of metal 3D printing. Well, size is a limitation. And I have to admit, this part being 22 inches long, it was a little bit of a challenge finding a company that had a big enough machine to metal 3D print this. Two, I would say cost is a consideration. It can be expensive depending on the size and actually the volume of the part, the metal that it's using to produce the part. But in today's day and age of equipment and technology advancements, we're actually seeing this price come down quite a bit. We're looking at about $4,000 worth of 3D printed aluminum parts sitting in front of me versus some of the build aluminum quotes I was getting were $6,000, $7,000. So don't always write off metal 3D printing as just too expensive immediately and not consider it. You might actually be surprised by the prices you can find. All right, so let's wrap this up. Finalizing this project, there's some things that, we should reflect on, lessons learned, right? Or things we would adjust. These were all provided to me as is. I gave a little bit of feedback on manufacturing. We critiqued a few things, but ultimately the parts were kind of designed for both additive as an end solution and billet as an end solution. Had I had the chance to start from scratch, I think there's considerations in the design that I would have edited or made slightly different, knowing that metal 3D printing was ultimately going to be the solution. Areas where I could remove material that's not necessary, maybe do some generative design for optimization. And the point of that is really we would just save some cost of manufacturing. That's the big win there, and maybe add a little bit of strength in specific places. But for this project, I think metal 3D printing was an absolute awesome solution. And I'm really excited to see this going into the project as they continue to keep incorporating a lot of additive manufacturing solutions into this build. It's been a very exciting project to work with them on.